In this video, I will explain how to solve a Leontif input-output matrix. So let's jump into an example. Consider the following three sectors with technology matrix A and external demand D. Determine the output level that must be produced by each sector. So we are told that some economy has three sectors, and here's the technology matrix for those three sectors. Now, here's how we interpret the values in this matrix. The first column represents the inputs needed to produce 1 unit of the good produced by sector 1. So in other words, to produce 1 unit of the good from sector 1, it requires an input of 0.01 units from sector 1, so the same sector. It requires 0.02 units from sector 2, and it requires 0 units from sector 3. And similarly, the second column in this technology matrix says that to produce 1 unit of the good produced by sector 2, that requires 0.002 units from sector 1, 0.004 units from sector 2, and 0.01 units of the good produced by sector 3. And the last column has a similar interpretation. And we're also given this external demand matrix, which tells us the total units demanded from sector 1, sector 2, and sector 3. Now, the way that we can figure out the output level that must be produced by each sector, we can call the output level X. That will be equal to I minus A, the inverse of this matrix, where I is the identity matrix and A is the technology matrix, multiplied by D, the demand matrix. So we can first start solving this by figuring out what is I minus A. So I, that's the identity matrix. So when we're given a technology matrix like this, the identity matrix will be the same size as this matrix, but it will have 1s along all of the diagonal elements and 0 everywhere else. So here's what that looks like. So here is I, the identity matrix. Then we're going to subtract A, the technology matrix that we were given. So I'll go ahead and rewrite that. So when we take the identity matrix and we subtract the corresponding elements from the technology matrix, here's what we end up with. Okay, so here's what we end up with. So this is our I minus A matrix. And remember, we want to find the inverse of this matrix. So to find the inverse of a 3 by 3 matrix, here's the formula we use. 1 divided by the determinant of the matrix multiplied by the adjoint of the matrix. So let's go ahead and figure out what that is. So we'll start by finding the determinant of this 3 by 3 matrix. So I'm going to clear a little bit of space here. Okay, so we said we want to find the determinant of this 3 by 3 matrix right here. So here's the trick you can use to find the determinant of a 3 by 3 matrix. Take the first two columns and rewrite them on the outside of the matrix. Then to find the determinant, you're going to multiply the values along the diagonals and add them together. And then from that, we're going to subtract all of the values multiplied along the cross diagonals added together. So when we do that, here's what we get. So after we perform all of those multiplications, we end up with a determinant of 0.9662792. So remember we said that to find the inverse of this matrix, we use the formula 1 divided by the determinant times the adjoint. So we just found the determinant, so now we need to find the adjoint of this matrix. So here's how we can do that. Okay, so we said we want to find the adjoint of this matrix. So the adjoint is going to be equal to the cofactor matrix, which I'll abbreviate as C, transposed. So how do we find the cofactor matrix? Well, to find that matrix, for each element of the cofactor matrix, here's what we do. For the element in the first row in the first column, we temporarily imagine that we remove the first row and the first column, and then we find the determinant of the resulting 2 by 2 matrix. So if we consider this as a 2 by 2 matrix, the determinant would be these two values multiplied together minus these two values multiplied together. So let's go ahead and write that down for the first element. So if we take 0.996 multiplied by 0.98 and we subtract 0 times negative 0.01, we end up with 0.97608. So that's our first element in the cofactor matrix. Now, one other thing that I should mention is that when we have a 3 by 3 cofactor matrix like this, the value that we just calculated is called the minor. To get the cofactor, we have to multiply it by either a positive 1 or a negative 1 in the following formation. So for the element in position row 1, column 1, we just multiply it by a positive 1, so it stays as a 0.97608. Now to find the next element in the cofactor matrix, so that is the element in column 1 in row 2, we temporarily imagine that we eliminate column 1 in row 2, and we find the determinant of the resulting 2 by 2 matrix. So that would be negative 0.002 times 0.98 minus negative 0.04 times negative 0.01. So when we do that calculation, here's what we get. So when we do that calculation, we end up with negative 0.002, and then we have to multiply it by a negative 1. So this would actually turn it into a positive 0.002. So for this element in the cofactor matrix, we get 0.002. Now I'm going to go ahead and show what all of the remaining values are in the cofactor matrix, since this is a pretty tedious process. Okay, so here's what we get for the cofactor matrix. Now we said that the adjoint is going to be equal to this cofactor matrix transposed. So in other words, the first row is going to become the first column. So here's what that looks like. Then the second row will become the second column. So here's what that looks like. And lastly, the third row will become the third column. So here's what that looks like. So here is our adjoint matrix. So now we have everything we need to find the inverse of this matrix. So let's go ahead and write that down. Okay, so just to recap, here's our I minus A matrix. We said that to find the inverse of this matrix, we take 1 divided by the determinant of the matrix times the adjoint of the matrix. So let's go ahead and write that. We have 1 over the determinant we found was 0.9662792. And we're multiplying that by the adjoint matrix, which we found was this. So when we take this quantity and we multiply it by every element of this matrix, here's what we get. So this is our inverse matrix of I minus A. So remember, the very last step is we're going to take this inverse and we're going to multiply it by the demand matrix from earlier. So I'll go ahead and write that down. So we said that X, this matrix that tells us the output level for each sector, is going to be equal to this inverse matrix multiplied by this D demand matrix. So we see that X is equal to, this is the inverse matrix that we found, multiplied by, this was the demand matrix that we were given at the beginning of this problem. So when we multiply these two matrices together, here's what we get. So this is our final answer. We find that sector 1 needs to produce 113.79 units in order to meet the external demand of 100, along with the input needed during the production process. We find that sector 2 needs to produce 203.09 units to meet the external demand of 200, along with the input needed during the production process. And lastly, we find that sector 3 needs to produce 308.18 units in order to meet the external demand of 300, along with the input needed during the production process.